Good afternoon, everybody. Welcome to a wonderful afternoon at Chem 170, Organic Chemistry from Elgin Community College with your host, me, Dr. White. All right, been having a weird day today with electronics and computers. So if I ever get kicked off, wait around, I'll log back in. That didn't happen earlier, but the other school, for some reason, Zoom knocked out my whole meetings, so I had to reset it up. Anyways, I'm here, you're here, let's get going. All right, important thing, this Wednesday, everybody see test number 2, important information, thank you. This Wednesday, I will be giving test number 2. Just like test number 1, you will download a password protected PDF file from the assignment area of D2L. That will be available tomorrow afternoon or maybe even a little earlier. Excuse me. And right after class on Wednesday, 4 p.m. or maybe a little earlier, I will send out an email with the password for the test 2 PDF file. You'll have until Thursday, 1 p.m. to finish test number 2 and upload your answers to the assignment area of test of D2L. Should take about 40 minutes, but if you need more time, just make sure you have it uploaded by Thursday, 1 p.m. That's the one nice thing about Zoom. I can give you extra time. If we were face-to-face, because right after Wednesday, we'd normally have a lab, you'd have 55 minutes. Even then, like I said, it should take you about 40 minutes or so, assuming you've done the practice problems. Hopefully you have. All right, test number 2 has 9 pages, 10 problems. Some of the problem are multiple part. It covers alcohols, thiols, ethers, ethylene oxide, aldehydes, and ketones. The points breakdown, 11 points general knowledge, nomenclature 34. Remember, there are 2 types of nomenclature question. Here's the molecule, give the IUPAC name. And then here's the name, both common and IUPAC I can put down, draw the structure. And finally, reactions are 60 points. Of that, the majority are give the organic product or product problem. You've seen me do that many times here in class. Now, I just looked at the schedule. We're already in week 8, almost halfway through the semester. Wow, has this been going quick? See, time flies when you're having fun with organic chemistry and Dr. White. All right. And there'll be, I think, 3 or 4 synthesis problems, which are give the starting materials for the following. As always, this will not be an open notes test. By the way, I put stuff in the test to find out if somebody's been looking at their notes or not, or going online to wherever using, say, Google to help you out. All right, today, like I said, I'll do a test number 2 review, and we'll have our regular Zoom meeting and lab on Wednesday. Any questions? Well, in that case, let's do the review for test number 2 first. Then we'll do the aldehydes ketones problem set. And if we still have time, which we probably will, we'll continue on with carboxylic acids, which will be on test number 3. All right, let's talk about functional groups. Alcohol. And just to remind you, an alcohol has this general structure. Don't forget what you're seeing on the screen right now is available in D2L in lecture section, and it's hiddenly named, secretly named test 2 review. All right, so you have an alcohol. How do you name it? Find the longest chain or ring with the hydroxyl group carbon, carbon with the OH group on it. Name it as an alkane. Drop the E, add OL. If it's acyclic, you need a number. You should have had this. You need a number which carbon the hydroxyl group is on. Remember, for a chain, you always start numbering from the end, not in the middle, and you give that number the highest priority, meaning the lowest. If there's a ring, no number, because that carbon is always going to be number 1. Now, here I have the structure phenol. That's the common and the IUPAC name. Now, I taught you common names, and that's where you name the R group as the alkyl group that's attached to the hydroxyl group, and then add the word alcohol. Oh, remember, rubbing alcohol is 70 to 90% isopropyl alcohol and water. And what do we mean by that? Common name. And on a common name, I'll never ask you to give the common name, but given the common name, you should draw it. The IUPAC name for this is ethanol. But the common name, the R group, ethyl, and then add the word alcohol. And if you look on hard spirits or wine, you'll see ethyl alcohol percentage. But if you go in a gas station, any of you go in a gas station, see this gasoline contains up to 10% ethanol? And say, oh, I know that. That's an alcohol. Remember, organic chemistry is all around you, and it won't hurt for you to think about it when you're not in my lecture. All right, now, how do you make an alcohol? Well, this was the only reaction I know that can be on 2 tests this semester. You have a double bond, react the acid and water. Remember, water is HOH, and you break the pi bond. One carbon gets H, the other gets OH. It follows Markov-Nikov's rule. The carbon with the most hydrogen gets the hydrogen, and the other carbon double bond gets the hydroxyl group. Again, Markov-Nikov's rule. Now, reactions of alcohols. If you take an alcohol, carbon with a hydroxyl group, adjacent carbon right next door with a hydrogen, reacted with sulfuric acid, H2SO4. The little triangle means heat. Sometimes I'll put a number like 182. I didn't here. You'll get a double bond, and it follows Zasev's rule. And the way I've interpreted for this class or taught Zasev's rule, you get the double bond product that has the most carbon atoms directly bonded to the carbons of the double bond. So let's take a look at this. This one can be challenging. So the question is, what's the product or products of the following reaction? Clean up this hydrogen. Hold on. That looks better. So how do you do this? Well, you look what's different, what's not carbon, what's not hydrogen, Should get your attention like that. And, ooh, oxygen with a hydrogen and a carbon, that's an alcohol. But since we're reacting it with sulfuric acid, we'll get a double bond, and it follows Zasev's rule. Years ago, I used to be writing out Zasev's rule and look at it. Did I write his name right? And I got lazy, just like Markovnikov, and just put the first initial, but I still say it. So if we look at this molecule, here's the carbon with the hydroxyl group, adjacent carbons, A and B. If I lose a hydrogen from A and the hydroxyl group, this is the molecule I get. If I lose a hydrogen from B and the hydroxyl group, remember, you don't break carbon-carbon single bonds. This is the molecule you get. Again, the general reaction, hydroxyl group and an adjacent carbon, hydrogen, and between those two carbons, you form a double bond. Now, Zasev's rule works by, you get the product that has the most, listen carefully, carbon atoms directly bonded to the carbons of the double bond. So if we look in A, there's 1, 2, 3 carbon atoms directly bonded to the carbons of the double bond. If we look at B, there's only 1. You don't count this or this. Just the carbon atoms directly bonded to the carbons of the double bond. So this has 1. And the question is, in Zasev's rule, when you have a choice like this, you get the molecule that has the most carbon atoms directly bonded to the carbons of the double bond. Well, we got to use our high-level math in Dr. White's class now. Which is greater, 1 or 3? And hopefully you all picked 3. So this is the answer. This is not. Okay? And that's how you do Zasev's rule. And that's why I stopped now to show you this. And by the way, this video will be of our lecture today. By tonight, 10 p.m., we'll be on Zoom, not Zoom, my YouTube channel for Chem 170. I hope that helps all of you people out there. All right, let's continue on. Another reaction you should know, if you take an alcohol, carbon with a hydroxyl group, reacted with an acid HX, where X can be chlorine, bromine, or iodine, you replace the hydroxyl group on the carbon that has the hydroxyl group with the halogen from HX. Now, as I showed in class, but I won't put on a test, if you have more than one functional group, that HX may react with it. So it was discovered by, I don't know who the chemist was who did this. One of these days I got to look it up. Take an alcohol, react it with thionyl chloride, excuse me, SOCl2, you replace the hydroxyl group on the carbon that has the hydroxyl group with the chlorine. Next, I taught you about primary, secondary, and tertiary alcohols. I will never ask on a test or the final, is this a primary, secondary, tertiary alcohol? But you need to know that when you react by oxidation, and the O in bracket O means oxidizing reagent. Being the nice person I am, don't tell anybody about that. But instead of having you memorize oxidation reagents like potassium permanganate, sodium dichromate, and so on, and organic chemists do this as an abbreviation, bracket O, close bracket. And if you take a primary alcohol, you lose the hydrogen from the hydroxyl group and the hydrogen from the carbon that's bonded to the hydroxyl group, and you form a aldehyde, which you learned a couple of chapters later. That's an aldehyde. If you take a secondary alcohol and oxidize it, O bracket O close bracket, same thing, lose a hydrogen from the hydroxyl group, hydrogen from the carbon it's bonded to, and you'll get a ketone. Now, tertiary alcohols do not react, as you learned from the lab in alcohols, but I will never, ever, I will never, ever put on a test or the final a reaction where the correct answer is no reaction. That will never, ever be an answer on my test or finals, never. All right, let's move on. Talk about thiols. Thiols is RSH. We're like an alcohol, but you replace the oxygen with a sulfur. And the first thing you should know is they stink, like a skunk odor stink, because skunk odor is water and the thiols mixture. But the other thing you really should know is thiol, T-butylthiol, is put into natural gas to make it so you can smell if there's a leak. And I talked about that tragedy in Texas back in the 1930s, which caused people to, how do we smell a gas leak? Because it killed a lot of children and teachers. And they decided to add a thiol to that. Next, I talked about ethers. And ethers, ROR prime. And I didn't ask you to learn IUPAC. Common name, name each R group as an alkyl group and add the word ether at the end. Now, how do you make ethers? The Williamson ether synthesis. If you take an alkoxide, RO minus and A plus an alkyl halide, R prime X, or X can be chlorine, bromine, or iodine, you get an ether. Remember, the oxygen and RO minus bonds to the carbon in the halogen, has the halogen on in R prime. Again, the carbon with the halogen is what bonds to the oxygen in R prime, and you get a salt too. Next, I talked about epoxides, really just one, ethylene oxide. I will never ask you to know the name of ethylene oxide, but there are two reactions I did teach you. One is if you take an alcohol and react it with one molecule or mole of ethylene oxide, you'll make the ether alcohol, ROCH2CH2OH. Now, if you take an alcohol and react it with, notice the N in front of the CH2CH2O, the ethylene oxide, that's N molecules or moles, then you get a polyether alcohol, which is written like this, where N, the number of times OCH2CH2 repeats, is from this N. Now, listen carefully. Common mistake on test number 2. Students put the hydroxyl group inside the bracket. No. That doesn't exist. And besides, no, it's wrong, and I'll mark it wrong. So make sure the OH for this reaction goes on the outside of the bracket. Next, we got into one of my favorite areas, aldehydes and ketones. Aldehyde, carbon, double bond to oxygen with a hydrogen and R group on it. Ketone, double bond to oxygen to carbon, and that carbon has R and R prime. Now, nomenclature for aldehydes. Find the longest chain with the carbon double bond to oxygen, which you learned in the next slide or two, is called the carbonyl carbon. Name it as an alkane, drop the E, add Al. No numbers needed. Now, a word of caution. Alcohols have an OL ending. Aldehydes have an AL ending. Write it clearly, because you don't want me guessing. Is that an O or is that an A? Because I got a 50-50 chance of guessing. Nah, it's wrong. So be very clear when you write your O and A for the different endings between aldehyde or alcohol. You need no number, because in an aldehyde, the carbonyl carbon double bond to oxygen is always number one. Everybody knows that, so you don't need a number. I do need some water. This is thirsty work. Next, a ketone, carbonyl carbon double bond to oxygen with two R groups. Now, find the longest chain, or unlike an aldehyde, a ketone can be in a ring. Find the longest alkane or cycloalkane. Drop the E, add ONE at the end. Acyclic, you need a number. Which carbon is double bond to oxygen? And that always has the highest priority, the lowest number. In a ring, no number, because that carbon is always going to be number one. Always. Even if there are other functional groups, it's always going to be one. Now, there are two common names I asked you to learn. One is formaldehyde, and I have it written this way, but you could have also written it this way. That would be acceptable also. And formaldehyde, and I talked about the dangers, and also it's a very important chemical. My last US patent, I used formaldehyde, but it's got to be used safely. Formaldehyde is the simplest aldehyde when R is a hydrogen. Now, the simplest ketone when R and R prime are methyl is acetone. And acetone, nobody ever calls that molecule 2-propanone. Acetone, I don't know how it ever got the name acetone, but it did eons ago. Now, just to remind you, what's the use for acetone? Acetone is nail polish remover. You can see I polished my, no, I forgot to polish my nails. Did I tell you back when I was a little kid, I hate to say this, back in the 1950s and early 60s for a while too, if you went into a barber shop, they always had good ones, even most of them did, had a manicurist. And most guys, my grandfather used to, and my father did too, they'd have their nails done there, and then they'd put a clear coat of nail polish on there. Men never did colored, at least back then. I don't know about now. If guys, anybody polish their nails? Don't tell me. It's none of my business. But anyways, remember, acetone is one of the two molecules that's used for nail polish remover, and it's a ketone. Now, personally, one of the most important, if not the most important thing in organic chemistry is the carbonyl group. And that's, you should know how to write the carbonyl group. I have it here in red, and you should know how to describe what is a carbonyl group with the words. I have it right here, carbon atom, double bond to an oxygen atom. As I mentioned before, and I'll mention it again, if somebody were to ask me, Dr. White, what kind of chemist are you? And if I were really being honest, which I try to be, the only answer I could give is I'm a carbonyl synthetic organic chemist. And carbonyl, carbon double bond to oxygen, and a lot of the work I did in the chemical industry, not all, but a lot of it, dealt with carbonyl groups. And when I was in graduate school, getting my PhD, my research dealt with carbonyl groups. Dr. White loves carbonyl groups. And we'll learn later on, your skin, your hair, your clothes have carbonyl groups and other functional groups that we haven't touched on yet. All right, so how do we make a ketone? Well, I already showed you this. Primary alcohol, oxidized aldehyde. Secondary alcohol, oxidized ketone. Now, another way is called Friedel-Crafts acylation. R double bonded to a carbonyl group is called an acyl group. And if you take benzene, react this is called an acid chloride, and aluminum trichloride, this carbonyl with an R is now bonded to a benzene ring, and it's a way of making aromatic ketones, where one of the R groups is a benzene ring. That turns out to be an important type of molecule, which I talked about. All right, let's go through the reactions. You take an aldehyde or ketone, and here R prime is hydrogen, it's an aldehyde. R prime is carbons, it's a ketone. R prime and R double prime can be bonded together, that's a ketone in a ring. If you take an alcohol, react it with an aldehyde or ketone, the presence of acid, alcohol, acid, ketone, or aldehyde. Keep your eye on the carbonyl carbon. What's attached to it, R prime or hydrogen, R double prime, still there. And then this becomes a hydroxyl group, then also the same carbon, oxygen, then R. It's called a hemiacetal, hemiketal, which I will never ask you on a test. But maybe you will like to know that for other classes. Remember, watch what you're doing, read carefully, because that fell off. Now it's back. All right, you take an aldehyde or ketone and react it now with 2 molecules of alcohol plus acid catalyst, H plus. Keep your eye on the carbonyl carbon, what's attached to it, R prime or H, R double prime, still there. Now we have an acetal or acetal or ketal, 2 oxygens on each oxygen, the R group from the alcohol. Remember the special case that I talked about when the 2 alcohols are in the same molecule, and that's called ethylene glycol, and that's what Dr. Herbert Stort created, what's called a protecting group with this reaction. For some reason, students always forget that dark double bond there, a single bond. All right, now, if you start with a hemiacetal or hemiketal, acid and water, and this is one of the 2 reactions we'll come back to, actually all these 4, and I'll go through and mark them again. And we'll talk about them, because that's how Mother Nature makes carbohydrates, and that's how your stomach breaks them down. And if you take a hemiacetal or hemiketal, react with acid and water, you get back to ketone or aldehyde and the alcohol you would have used to make that compound. If you take an acetal or ketal, where both of these have a carbon with 2 oxygens, both single bonded. And this you get back the aldehyde or ketone you would have used to make that hemiacetal ketal plus the alcohol. Remember, you don't have to balance anything. But I've had students get upset. Oh, isn't there a 2 there? So there's a 2 there. You don't have to. I wouldn't, except I don't like upset students. Now, listen carefully. This reaction, aldehyde or ketone with an alcohol acid catalyst. This reaction, aldehyde or ketone with 2 molecules or moles of alcohol plus acid. I will never do a synthesis. I'll just ask what are the product or products. Same thing for the special case. Then the next 2 right here, where you do acid hydrolysis, acid and water, I will never put down as a synthesis problem. That's not being fair. I try and be fair. All right, let's move on. Now, this next one could be a synthesis problem. Take an alkyl halide reactor with magnesium, Mg, where X can be chlorine, bromine, or iodine. Then you form the Grignard reagent, RMgX. Now, if you were to put down RXMG, I'll mark it wrong because that doesn't exist. That magnesium is bonded to the carbon that had the halogen, and the halogen is bonded to the magnesium. All right, that I can put on the synthesis. The next one I won't. And that is when you take an aldehyde or ketone, first step, react it with a Grignard reagent. X can be chlorine, bromine, or iodine. Second step, acid and water. Keep your eye on the carbonyl carbon. What's attached to it? Our prime or H and our double prime will still be there. You'll have a hydroxyl group. Then the important thing about the Grignard reaction, between R triple prime and the carbonyl carbon, you'll form that very special, very rare carbon-carbon single bond. The Grignard reaction right here, I will never put a synthesis problem on. I will ask you to give the product or products of the following reaction. Next, if you take a aldehyde or ketone, remember this is a pi bond and this is a sigma bond. And you learned you could break the pi bond by adding hydrogen to catalyst in a carbon-carbon double bond. Well, you can do the same with a carbon-oxygen double bond. And the catalyst can be nickel, platinum, or palladium. You break the pi bond, and each now atom of the double bond gets a hydrogen. But as I showed, sometimes you may have other things this will react with. So another way that Dr. H.C. Brown of Purdue found out or discovered is if you use the reagent LiAlH4, lithium aluminum hydride. First step that, second step acid and water, and essentially does the same thing. You break the pi bond and each atom gets a hydrogen. Now, the nice thing about lithium aluminum hydride, which I won't test in this class, is it will not react with a double bond, carbon-carbon double bond, but it will react with a carbonyl double bond. Now, we talked about aldehydes and ketones, and the carbon attached to the carbonyl carbon, the alpha carbon, has acidic protons. If you react, and here my special gift to you, and I didn't have to do it, notice I copied the same aldehyde twice. The alpha carbon, you can take off a hydrogen and get an enolate anion, and the red arrow shows you how that attacks the other carbonyl, opens it up to an alcohol, and you form this bigger molecule called the Allyl condensation. And the nice thing about the Allyl condensation, you make a carbon-carbon single bond. Very rare, very special, very nice. With that, I'm done with the review. Give me a thumbs up if it was helpful for doing the review today. Thank you. Thank you. All right. Any questions about anything dealing with test number 2 this Wednesday? I'm listening. Wait, my speaker's up there. I should do this. Or I look at the chat. All right, looks like the answer is no. So, are we doing time-wise? We're doing good. All right, everybody see the ketones and aldehydes problem set? Thank you. You guys are some of the fastest thumbs up people I've ever had. My morning class this morning is like, you want me to do what? All right, they don't even have their webcam on. All right, first of all, give the IUPAC name for the following. Remember that fun game, circle and name the functional group, 2 points each, which we played a couple of times? Well, you've got to know what's the functional group to name it. And how do you do that? You look for what's different, what's not carbon, what's not hydrogen, to get your attention like that was like that. That sounded better. And oxygen, double bond to carbon, hydrogen, carbons, aldehyde. And how do you name that? Find the longest chain with a carbonyl carbon, name it as an alkane, 4 carbons. Guess what? Butane. I was thinking double bond, should be butane. Drop the E, add Al, butanal. No number because the carbonyl carbon is number 1. Now, if we look at, let's do a harder one for B in a little while. I think I got a better one. I do, so we'll do that. But let's look at C, the ring. What's different? Oxygen, double bond to carbon. Carbons here, carbons here. This is a ketone in a ring. How many carbons in the ring? Count the bends, 1, 2, 3, 4, 5, 6. As cyclohexane, don't forget the cyclo, but it's a ketone, drop the E, add ONE, cyclohexanone. Now, you don't need a number because the carbonyl carbon is always 1. And you number the other alkyl groups in a way to give them the lowest numbers. If you count clockwise from the carbonyl, 1, 2, 3, 4, and I did, you'll see on carbon 3 a methyl, carbon 4 isopropyl. Now, if you'd put down, even though this is the correct IUPAC way, you put down 4 isopropyl, 3 methyl, cyclohexanone, I would give you full credit. Let's skip down to F. And here, what's different? Carbon, double bond to oxygen, carbons here and here, it's a ketone. How many carbons in the longest chain with the carbonyl carbon, carbon double bond to oxygen? Well, this way across is 8. If I go 6, 7, or 9, going down this way, 6, 7, 8. So 9 is the longest chain, no name. It's a ketone. Drop the E, add ONE. Now, what carbon is, since it's not in a ring, since it's acyclic, what carbon is double bonded to oxygen? And that's carbon 3, counting this way. You don't want the other way, which I didn't show on here, but 1, 2, 3, 4, 5, 6, 7. So which is smaller number, 3 or 7? And hopefully I'll pick 3. And that's 3 known and known. And on carbon 6 is an isopropyl group. Now, if we look at number 2, this is another type of nomenclature question. Draw the condensed structure for the following organic molecules. And here, how do you do that? Start from the right, move left. And Al ending aldehyde, if that were E hexane, 6 carbons, and the end carbon is a carbonyl, which I have on there. Now, as I mentioned before, I've learned, and I do, and I'm not going to break good habits, I write my carbonyls as far to the right as possible. If you'd put it on this side, it's just like rotating at 180 degrees. Left hand, close your eyes. Oh, look, something different. You just rotated 180. All right, let's do B. Ooh, cyclooctanone. Start from the right, go left, ONE ending, ketone. That were an E, 8 carbons. I have 8 carbons. And where's the carbonyl? Carbon 3. 1, 2, 3. Now, I do have a couple of common names, acetone and formaldehyde. And if we look at E, starting from the right, moving left, ONE ending, ooh, aldehyde or ketone. This for an E, cyclopentane, 5-membered ring, and because it has ONE ending, one of the carbons is double bond to oxygen. And then on the carbon 2, that carbon is carbonyl carbon. It's always going to be 1. Carbon 2, I have a terbutyl group. Uh-oh. Don't look, don't look. I forgot a 3. See, I have CH3, CH3, CH. That should be CH3. Don't look, don't look. Oh, I feel so. No, I'm not. I don't like making mistakes, but I know, guess what? Now I made another mistake. On F, see on carbon 3, I have an isopropyl. That should be an N-propyl. CH2, CH2, CH3. I got G right. Anyways, let's do GF. Start from the right, move left. Al ending, aldehyde. If that were E, decane, 10 carbons. And carbon 3, don't look, it's supposed to be N-propyl. I have isopropyl. And carbon 2, a methyl group. All right. Now, as I said, on test 2, there'll be 3 types of questions. One's general knowledge. Do you happen to know rubbing alcohol has isopropyl alcohol in it? And that's an alcohol. Well, that's general knowledge. But anyways, the other type of question, nomenclature, we just went through the 2 types. And finally, reactions. Most of them will be give the organic product or product for the following. And here, what do we have? Primary alcohol, we're oxidizing it. And you get an aldehyde. And I got an aldehyde. Remember, for test 2, actually 3, 4, and the final, your 2 friends will always be how many bonds to carbon? 4. How many bonds to carbon? See, I'm ambidextrous. I can do it with both hands. Am I cool or what? Don't answer that. But anyways, remember, there's 4 bonds to carbon. The other thing is, do you break carbon-carbon single bonds? No, that's always going to be your friends taking any of my tests. And the final. Now, primary alcohol, oxidize, you get an aldehyde. Start with 2 carbons, you better end up with 2 carbons because you don't break carbon-carbon single bonds. And here, if you have a secondary alcohol, oxidize it, same thing, lose hydrogen here and here, form a carbon-carbon or carbon-oxygen double bond. And this is a ketone. And notice you don't break any carbon-carbon single bonds. You started with 2, 4, 6 plus 3 is 9. you end up with 2, 4, 6 plus 3, 9. Now, if you take a benzene ring, ooh, by the way, this is left justified. You can also write it CH3. Sometimes my software does that, and I didn't catch it. Obviously, I didn't, because here's the same thing, CH3. But carbonyl with a chlorine on it too. That's an acid chloride, aluminum trichloride, brittle crafts, acylation. I almost said alkylation. Should be acylation. And benzene ring, acid chloride, aromatic ketone. What's our methyl group? And here's the molecule you get. I give you some more chances to do that. All right, how are we doing time-wise? Doing good. Let's look at H. Look for what's different, what's not carbon, what's not hydrogen. Should have gotten your attention like that. Or like this. I had to get that in. I did. All right. Here we have what? Ooh, carbon double bond to oxygen. That got my attention. Hydrogen here. Methyl group. It's an aldehyde. It could have been a ketone. Ooh, carbon-carbon hydroxyl group. Alcohol. Acid catalyst. H plus. And what's attached to carbonyl carbon is still attached there. And it is. And then you'll have a hydrox group in OR, and the R group comes from the alcohol. Now, if we look at our carbonyl carbon, what's attached to it, hydrogen and methyl, is still there. I'll have my hydroxyl group and oxygen R. What's R? Ethyl. And if you have a ketone, same thing, carbonyl, carbons here and here, alcohol, acid catalyst. Keep your eye on this carbon. What's attached to it will be attached to it. R prime and R double prime. I have an OH and OCH3 because it's my R group. Now let's look at B. For some reason, students get upset, I don't know about upset, troubled with cyclic ketones. Look at the ring. What's different? Oxygen, double bond to carbon, carbons here and here. It's a ketone, where R prime and R double prime are bond together. Ooh, two of something. That's unusual. Carbon, carbon, carbon hydroxyl, two alcohols, acid catalyst. And keep your eye on the carbonyl carbon. What's attached to it, R prime and R double prime. The ring is still attached. Then two oxygens, then R. What's R? Isopropyl. And if you notice, see, I've done the same thing, except I have an aldehyde. And I just noticed it's time to take a break. Let's take a 5-minute break. I can get up and stretch, and I'll see you in 5 minutes. I'm back. Let's continue. And don't forget, there's no such thing as a dumb question. So always feel free to ask questions. Now, we just went through the reaction. And do I have? Yeah, I do have one where it's 1R group. If you have a ketone or aldehyde right here, I don't know if let's go through it again in case I forgot to do it. My short-term memory just got erased. All right, if you take an aldehyde or ketone, one molecule, what's different? Remember, name the functional group. Find what's different, what's not carbon, what's not hydrogen, should get your attention like that. And aldehyde or ketone, alcohol and acid, keep your eye on the carbonyl carbon. That's why I got the dot there. Am I nice or am I nice? Don't answer that. And what's attached to it, our prime and our double prime will be there in the product. But on that carbon, you'll have a hydroxyl group when it's one alcohol molecule, OR. In this case, H is our prime, methyl is our double prime, it's on that carbon, OH, oxygen, and my R group is ethyl. If you have two molecules of an alcohol, and here I have a ketone, aldehyde or ketone. Remember, when R prime is hydrogen, it's an aldehyde. When R prime is carbons, it's a ketone. Dr. White loves both. I do. And in a cyclic ketone, R prime and R double prime are connected together in a ring. Two, there is a two. Alcohols, acid catalyst. Keep your eye on the carbonyl carbon. That carbon still has R prime or H plus the R double prime. Now it has two oxygens, and each oxygen has the R group from the alcohol. Well, for this, R and R prime, or R prime and R double prime, are the ring. Here's my carbonyl carbon. This one right here will have my two oxygens. It does. And my R group's isopropyl. And there they are. Remember, as always, these are the building blocks chemists use, and Mother Nature too, to make new things that we use in our daily life. And now once you form, I think this is the one I forgot to do an example. Yep, I'll have to do a special example for you. If you take this molecule, look for what's different. There's only two places in organic chemistry, and both give the same product. Notice there are two oxygens single bonded to the same carbon. Each oxygen has R groups on it, plus there's stuff on that carbon already. You could have R prime, and it could be H, which it is, and R double prime, these carbons. And on the oxygen, the carbons are R. Acid and water, H plus is acid. And you get back the aldehyde or ketone plus the alcohol you would have used to make that. You want to put a two there, you can't, you don't have to. And this example, R prime hydrogen, R double prime ethyl, you get this aldehyde. And then R is methanol or methyl, and you get this alcohol, methanol. And when it's in a ring, same thing. Here's the carbon with the two oxygens. That will be double bonded to an oxygen, a ketone, and then the R groups on the oxygen become the alcohol. Please note that the carbon with the oxygen here will be the carbon with the hydroxyl group in the alcohol. The carbon with the oxygen here will be the carbon with the hydroxyl group in the alcohol. Now, what I forgot in the problem set, Dr. White, Hold on a second. Let me try an experiment. What I'm doing is seeing if we can stop that screen from freezing. We'll see if it works or not. I think I'm still, next week I'll order. I should have, but I've been so busy, more memory for this machine. I've got so many things open on there. Wow. All right, let's get back. To the problem set, and now I got to open this up again. Oh, that's why I didn't do it. Hold on. Let's do that again. Not that much difference. All right. What I forgot to put, and let me screen share with you, is this reaction on the problem set. We did it in class, but I forgot to put it on there. And keep your eye on the carbonyl carbon, or the carbon with the two oxygens. It becomes a carbonyl carbon. And this was in the review I just talked about. Plus, the R group here becomes an alcohol. And this reaction I'll never give as a synthesis problem. And why don't you try this one? Give the product or products for the following reaction. And on a test for this one, I'd put a plus there to let you know there are two products. And remember, since we did the alcohol lab 2 weeks ago, if you already handed it in last week, which you should have, there's no lab we'll actually do on Wednesday, but we'll still have our Zoom meeting. Well, actually, we will do a lab. We'll be doing the distillation lab. Last week, we didn't do a lab. It's time for a vacation. How many more weeks till Thanksgiving? Oh, wait, it doesn't happen in this class. But in Illinois, whenever voting is, November or whatever, I don't I don't know which day. It's a Tuesday. All schools, all banks, everything will be closed. It's a state holiday to give everybody time to vote. Speaking about voting, time out for a personal message. Remember, brave men and women have died so we can vote. I have never missed a major election. I think all my life, I've been voting for many decades. I missed one minor election for a local village election because I happened to be in Germany and I forgot to get an absentee ballot. And that's the only time. Right now, sitting on my dining room table, I have my ballot, mail-in ballot, that either today or tomorrow, by Thursday, it will be in the mail. And then once again, I voted, and you should vote. If you're not registered, in the state of Illinois. It's very easy to register. You can find out online. Go to, I think, the Secretary of State's website, but please register, please vote. I'm not saying who to vote for, even though you know who I am, begins with the letter D. But anyways, you vote. The most important thing is people vote. All right, let's get back to this. Everybody done? Give Andrew a little while to finish up. All right, my turn. Look for what's different. Ooh, my pen stopped working. 2 oxygens to the same carbon. One's a hydroxyl group. One's an oxygen. It's got carbons here. I'll call that R. It's got carbons here and here. I'll call that R prime, but that could have been hydrogen, and R double prime. This is one of the 2 cases I know of in organic chemistry, the only 2, when you have 2 single bond oxygen to the same carbon. And when you're reacting with acid and water, what's attached to that carbon still will be attached to our prime or hydrogen, our double prime, and that will now be double bond to oxygen. And then this R group forms an alcohol. So here's our R prime, our double prime, R. Keep your eye on this carbon, which is this carbon, which becomes this carbon. What's attached to it? Methyl and ethyl. And plus, the R group here comes from the alcohol, and that's N-propyl. The carbon up here with the oxygen, this carbon will be the carbon with the hydroxyl group. And that's how you do it. Oh, let's try one more. Your turn. We'll give everybody time to finish. And I should have put here plus. All right, everybody's finished. My turn. What's different? Ooh, oxygen here and here to the same carbon. One's a hydroxyl group, one's an oxygen with carbons. And that same carbon, I could have had R prime, but I have a hydrogen. And this carbon I'll call R double prime. And when you react that with acid, H plus, and water, keep your eye on this carbon. What's attached to it? R prime or hydrogen, and R double prime is still attached to it, and it'll be double bond to carbon. And the next thing, this R group will form this alcohol. So we keep our eye on this carbon, which is this carbon. Hydrogen is R prime, and methyl is R double prime, and it'll be double bond to oxygen. Then my R group here for the alcohol, 1 carbon. And that's how you do it. Everybody done copying this down? Who wanted to copy it down? Don't forget, you can always go back and look at the video. All right, let's continue on. If you have a ketone or aldehyde acid catalyst, what am I saying? Acid, hydrogen. I got acid on the brain right now. Hydrogen and catalyst. Catalyst can be nickel, platinum, or palladium, which I didn't write down. You break the pi bond of the carbon-oxygen double bond, and each atom gets a hydrogen. Do you break carbon-carbon single bonds? No. So I have 4 across. I end up with 4. Break the pi bond. This carbon has a hydrogen, and this gets an oxygen gets a hydrogen. Now, you could have also written it this way. Either way is correct. And same thing here. Break the pi bond. Each atom of the carbon-oxygen double bond gets a hydrogen, and everything else stays the same. And if I have a ring, same thing. Break the carbon-oxygen double bond. You don't show the hydrogen on the ring, but the oxygen gets a hydrogen. Now, similarly, if you have an aldehyde or ketone reacted with lithium aluminum hydride, LiAlH4, second step acid and water, you get the same reaction. You break the pi bond, and each atom of the carbonyl group, carbon double bond oxygen, gets a hydrogen. Do you break carbon-carbon single bonds? No. So if I look at E, our prime is hydrogen, our double prime methyl, break the pi bond, and here's what I get. That's a funky looking hydrogen down here. Wow, that's really funky. And, or you can write it this way. Oh, I just saw another thing I forgot to put in here. And for you at home who are not watching this live, meaning those people seeing my YouTube, you can put pause after I write the problem. You'll have as much time as you need to finish it. And this is how you make the Grignard reagent: alkyl halide or chlorine, bromine, or iodine, magnesium gives you the Grignard reagent. And I'll let you have fun. You do it. What's the product or products? Oh, if you haven't figured out, this is one of the longer problem sets of the semester. And we'll give everybody time to finish. All right, everybody's finished, so I can get to work. And look for what's different, what's not carbon, what's not. Ooh, bromine, a bond is carbon with carbons. alkyl halide, where X can be chlorine, or in our case, bromine, or iodine. React it with magnesium. This is a fun reaction to run and very useful. I know I've done it enough times in my life. And you get the Grignard reagent. What's R? This. And the carbon with the halogen will be the carbon magnesium is bonded to. 1, 2, 3, 4. This carbon, and on that carbon will be the halogen, Br, and there are 4 bonds to carbon. Everybody get that? All right, let's continue on. Oh, let me give you another one. Let me not cheat you out of it. And the question is, what would be the product or products for the following reaction? All right, I better get to work. What's different? What's not carbon? What's not hydrogen? Should get your attention. Ooh, a chlorine on a carbon. Alkyl halide. Ooh, magnesium. And this is the Grignard reagent formation or synthesis reaction. And remember, X can be chlorine, which in our case it is, bromine, or iodine. And what's our R group? Right there. So you break carbon-carbon single bonds? No. So I won't. This carbon will now be bonded to magnesium. And my halogen is chlorine. And that's how you do it. Now, if you have the magnesium after the chlorine, I will mark it wrong and give you 0 points, because it is. I assume everybody's done copying it down, needs to copy it down. Nobody's screaming, stop. All right, I'll continue. Now, once you have the Grignard, what can you do? The Grignard reaction. And if we look at A, we have a ketone. Remember, look for what's different. Oxygen, double bond to carbon, carbons here and here, ketone. And first step, methyl CH3MgI, a Grignard. Second step, acid, H plus and water. And keep your eye on the carbonyl carbon. What's attached to it is, you'll get an OH on that carbon. And then the very special thing, a carbon-carbon single bond between that carbon with the OH and the carbon in R triple prime with the Grignard. Well, in this case, here's R prime, R double prime, R triple prime. Here's my carbonyl, and this is the product I have. And you could also draw it this way as I show you on there. Now, if we look at C, ooh, we've got a ketone. Carbonyl's right there. And notice we have carbon-carbon, ooh, magnesium iodide, a Grignard, second step acid and water. What's attached to that carbonyl, the ring, still will be. That carbon is this carbon right here. It opens up, will have a hydroxyl group. What's my R triple prime? Isopropyl. Now, another mistake I caught last night in this problem F down here, there's an extra CH2. There should be only one, two between the methyl and this carbon with the OH. I have 1, 2, 3. So there's an extra CH2 there. Just put an X through it. It shouldn't be there. But let's look at this reaction. Let's look at E because it looks like fun, and it is. If you look at this, my gift to you is notice they're both the same molecule, an aldehyde. And I'm reacting with sodium hydroxide, and the problem said I forgot to put water down there or another solvent. And the alpha carbon has acidic protons. You'll remove it, and it forms the enolate anion, and that attacks the other carbonyl carbon of this second aldehyde. And that forms a carbon-carbon single bond. And it's called the Allyl condensation. When it does that, the carbonyl carbon of the second aldehyde becomes an alcohol. So if we look at E, what's R? A benzene ring. Or another way, here's my alpha carbon, attached to carbonyl. I form, so I get all in on this together, looking nice. The world's longest carbon-carbon single bond, but it works. And the carbon with the that was attacked becomes a OH. What was attached to it is still there. And that's how you do the Grignard. Let's have some fun. And here's some fun for you. What would be the product for the following reaction? And to help you out, the general reaction is above it. Thank you, Andrew, and we'll give everybody time to finish. All right, everybody's finished. So if we look at this reaction, what's different? Ooh, I'm missing a line here. That's an H. It's an aldehyde, carbonyl with hydrogen and carbon. It's the second same aldehyde, and base and water, the alpha hydrogen, you'll pull off a proton formed enolate anion, it will attack that. Now you could say this is R and R prime, or R, and draw the structure based on this. I'm having fun, so I'm not going to do that. I have here and now that attaches to this carbon, which will have a OH group. And then hydrogen, what's attached to that, 3 carbons, will still be attached. And that's how you do it. And that's the Allyl condensation. All right, everybody copy down what they need to copy down. And I gave you some examples. I also told you how to correct this mistake down here. And with that, we've done the aldehyde ketone review. Any questions? I guess not. I had to open up a file. And last week, we started talking about carboxylic acids. And carboxylic acids has a carbonyl with a hydroxyl group and an R group on it. That's a carboxylic acid. And how do you name that? You find the longest chain with the carbonyl carbon, name it as an alkane, drop the E at the end of the A and E, notice I want colorful, and add the letters OIC in the word acid. Like an aldehyde, the carbonyl carbon is always number 1, and you don't need a name. And you number everything else like you've done before. And let's take a quick jog down memory lane. And I would ask you, give the IUPAC name for the following molecule. Remember, drop the E, add OIC in the word acid. Six across.
I don't know if we're looking at the right thing.
Oh, did I not switch? You're right. Now can you see it? Thank you, Ignacio. Thank you, Andrew. All right. So how do you name this? Ooh, carbonyl. Look for what's different. Oxygen, that same carbon, OH, and carbons. This is a carboxylic acid. Remember, this is not test 2 material. This will be on test number 3. Find the longest chain with the carbonyl carbon. Drop the E. Add the letters OIC in the word acid. And the carbonyl carbon is always number 1, but you don't need to put that because everybody knows that. So how many carbons longest chain? 1, 2, 3, 4. Oh, not bad. But 1, 2, 3, 4, 5, 6. Well, 6 is greater than 4. That's hexane. Drop the E at OIC and the word acid, hexanoic. And then once I say that, we now have, ooh, the isopropyl group. This is carbon 1, that's 2. So it'd be 2-isopropyl hexanoic acid. Good news, I'm not doing enunciation quizzes. All right, we did this already, but I thought I'd do a quick review. And don't forget, here are 3 common names. And this is the structure of formic acid. This is the structure of acetic acid. And this is the structure of benzoic acid. And remember, acetic acid you have in your house. You have vinegar, which contains 4% acetic acid and 96% water. And I talked a little about the longer chain ones. I talked about lactic acid and citric acid. And I think this is where I left off. All right, now, click. That was a loud click. Well, it's a big switch. Oh, it's bad humor Monday afternoon. But anyways, this won't be on a test, but some physical properties of, I have acids, it's really carboxylic acids. They have sharp or unpleasant odors. For the lower molecular weight acids, they have a sour taste to it, which is probably why you've never done shots of vinegar. Ugh. No, thank you. But anyways, they're polar and they have high boiling points because they can hydrogen bond, and the lower molecular weight, like acetic acid, are soluble in water. When you get real large, they're not. And we'll talk more about that in a later chapter. Now, Why is a carboxylic acid an acid? That's a good question. And the answer is, remember, a carboxylic acid, and this won't be on its S, dissociates in water it's in equilibrium to give us this. And that's definition of an acid. It's a proton donor, H plus, and it donates proton to water. Now, why is an acid an acid? Here's HA, acid base. You have this, and I have the same thing. The only thing my software doesn't like doing is putting a C there. So what makes a carboxylic acid acidic? Now, ethanol is not an acid, but acetic acid is. What's the difference? Well, let's just look in general terms. That's better. Now, what's the difference? Well, this one, I can move just electrons here to here and the switch is off. And I'll use a double-headed arrow because I'm using resonance. And when you can draw resonance forms of something by just shifting electrons around, guess what? It's more stable. It's more stable. You're going to go more to the right of this equilibrium, and it will be more acidic. Now, since if you take an acid, HA, plus a base, B, aren't those amazing, creative? But it works. You get a proton transfer and get the carbon or the anion plus the salt HB plus, which means if I have a carboxylic acid reacted with sodium hydroxide, this is called the carboxylate anion. And that's straightforward acid-base reaction. So if I have a carboxylic acid, a reactor with base, and sometimes you'll see me do it this way. And better yet, let's make it more general. MOH, where M for this class can be sodium, potassium, or lithium. And this is an acid. This is my base. And that would be the reaction. And sometimes I'll forget to put the water there. But this you don't have to put down because I asked for give the organic product or product for the following reaction. And what do we have here? Ooh, carbonyl with a hydroxy group and carbons, carboxylic acid, KOH, I can write as MOH. And remember, M for this can be sodium, which it is not. Lithium, it's not. But potassium, it is. And you form the carboxylate salt. So what's our ethyl? Keep your eye on the carbonyl carbon. What's attached to it, R, is still attached to it, ethyl. Another way is, do you break carbon-carbon single bonds? No. I start with 3 carbons, I better end up with 3 carbons. But I'll have now oxygen minus, potassium plus. And there are 4 bonds to carbon. I'll put in my hydrogens. Now, a number of years ago, I had a student say, why do you have to put the charges in? Can't I just write it like this? Like that. And he had a very persuasive argument. I said, all right, I will always write it with the charges because I think it looks cool. And Dr. White tries to be a cool dude. But if you write it this way, without the charges, I will not take any points off on a test. Because I'm also a nice teacher too. And if I look at it, we've gone a minute into our break. Wait, I'll wait until everybody's through copying it. Which means closer. So let's come back. I got to do some math now. Come back at not 3:52. It's a longer break, 2:52. And let me answer my phone. I'll see you in 5 minutes. I'm back. And so are you. All right, let's continue. I was talking about carboxylic acids are acids, and if you react them with a base, you pull off the acidic proton, that's the hydrogen on the oxygen, and you form a carboxylate anion. And I just gave you an example, and now it's your turn to have some fun. And the question would be, what's the organic product or product of the following? You also get water, but that's inorganic. And while you're doing that, let me remind you, last week I mentioned I changed my office hours. I believe it's in the syllabus, I'll have to check, but it's now, oh, I've got to look on Zoom, I'm not Zoom, on D2L, see if I changed that. I think I did, but I'll have to look. But anyways, my office hours are now Tuesday and Wednesday from 6 to 7:15. And if you have any questions, come on by. Now, if you need extra help, always feel free to email me and I see if I can set up a Zoom meeting for us to meet. That's a nice thing because we don't have to drive to ECC. That's the nice thing about Zoom and us using it. And when you're done, give me a thumbs up. Oh, I made a mistake up here. This should be a M for a general reaction. All right, everybody done? Not yet. Yep. All right, let's take a look at this. What's different? Ooh, two oxygens. Carbonyl, carbon double bond oxygen, hydroxyl group. On this carbonyl carbon, their carbons are sodium hydroxide, MOH, water, and M can be, in this case, it is sodium, it could be potassium or lithium. And what you get is the carboxylate anion. And here, this carbonyl is still this carbonyl. What's attached to it are an isopropyl group is still attached to it. The oxygen, I show charges, you don't have to. And what's M? Sodium. There are 4 bonds to carbon, so I can put in my hydrogens. And there you go. You make that carboxylate anion. And later in the chapter, I'll teach you how to name the IUPAC names, how to get the IUPAC name for carboxylate anions, but now it's too early. Oh, let's do another one. On test 3, don't forget, this is test 3 material, just like test number 2. I'll have a couple of synthesis problems. And there you go. What would you react with lithium hydroxide and water to make that compound? And let me clear something up because it doesn't look good. Now it looks better. Thank you, Ignacio. We'll give everybody a chance. Thank you, Andrew. We did give everybody a chance to finish. All right, how do you do this? Well, you look at the product and what's different? Ooh, carbonyl with an oxygen with a charge on it minus and a cation. And then I have carbons here. And that's a carboxylate anion. Oh, I have a base, lithium hydroxide, which I could also, in general, write MOH, where M can be, in our case, it is lithium, or it could be sodium, or it could be potassium. And what do you start with? A carboxylic acid. Well, I should mention this is one of the areas in industry. I worked at a company for a number of years that made carboxylic acids, and I'll talk later when we get into fats and oils. So what's my R group? T-butyl. Carbonyl, hydroxyl group. I know there are 4 bonds to carbon. And if you look here, I was not adding any carbons. So if I end up with 3 plus 2, 5 carbons, I better start 3 plus 2, 5 carbons. And I did. And that's how you do it. Now, let's do one more. Wait, I'll wait until everybody's through copying and checking their answer. Let's do one more. And here's one more for you to do. Now, sodium hydroxide and water will not react with a benzene ring. But there's other stuff in that molecule it will. While you're doing that, let me look up something. Huh. Hang in there a second while I'm trying to find something. Huh. Let me try one more thing. I can't find it. Sorry about that. All right, let's get back to this problem. What do we have that's different? Well, benzene ring, but that's not going to react with sodium hydroxide and water. So let's call that carbons. Ooh, carbonyl, carbon double bond oxygen, hydroxyl group, a carboxylic acid. And if you react that with a base, MOH, and water, where M is sodium, which in our case it is, or potassium, or lithium, you'll get the carboxylate anion. So what's our benzene ring? And I have my carbonyl, my oxygen. Now I'll have a minus charge. And what's M? Sodium. Now, you don't have to show the charges, but I always will. Now, this is a carboxylate anion. I'll teach you later on, but I'll use the name now. And that's called sodium benzoate. And why did I put this down? Well, one of the things you should be doing in my class is asking, why am I learning this stuff? And that's a good question. And the obvious answer is, well, you want to get a good grade. If somebody told you you had to take my class to get into a program like nursing or to college for a certain degree path. Well, why are we learning these things? Well, this reaction you just did, taking benzoic acid, that's the name of this molecule, to make sodium benzoate. Well, sodium benzoate for many, many decades, I don't know how many decades, has been used as a preservative in pop. Now, remember, Dr. White comes from the Chicagoland area, and stuff in a can or a bottle that's carbonated, non-alcoholic, we call that pop, not soda. And that's a preservative. Now, how it preserves or what it preserves, I have no idea. I'm not that kind of scientist. I'm a chemist and I know how to make it. I'm an organic chemist. I really know how to make it. And that's why you're learning these different reactions, because they make molecules that are used in our daily life. And through now through the end of the semester, we'll be encountering more and more cases like that. And because your instructor worked in the chemical industry and knows the real world, I can share this with you. And I did. All right, now, if you notice, a carboxylic acid is an acid reacted with a base, you get the carboxylate anion. Now, there's a special reaction I'd like to share with you, and that's the reaction of a carboxylic acid with sodium bicarbonate, which, in other words, in your house, baking powder. If you go into most people's house, they'll have a can of baking powder. The most popular brand is Calmet. There's a bizarre brand from Indiana called Gabler Girl. And a lot of stores now have their house brand, like Myers, etc. I haven't looked at it, but I'll bet you Walmart might. I haven't looked. But anyways, let me show you the general reaction on my whiteboard. It's here in the slide. Well, let's go to my whiteboard. And this is important. Let's look at all the products. And if we take a carboxylate anion, or carboxylic acid, got ahead of myself, a reactor with baking powder, sodium bicarbonate, you'll get the carboxylate anion plus water and carbon dioxide. Now this arrow tells you the CO2 is given off as a gas. Now I'm going to show you something, and you don't have to write it down, but where do you get all this from? Well, let's look at this. I can rewrite sodium bicarbonate like this. This proton transfers here, and you form the carboxylate anion plus this molecule. I'm putting it in brackets because you can't isolate it. This is called carbonic acid. And what I'm writing, you'll never have to do on a test. Well, this is unstable. It immediately breaks down to HOH, water, and you're left with 2 oxygens and a carbon, CO2. And that immediately goes faster than I can do even think about it almost. It's instantaneous once it's formed. And that's why you get the CO2 and water. So let's take this for a spin. But first, and we're going to do something different. And normally I say give the organic product or products, 3 points. But now 4 points, give all the product or products for the following reaction. So let me get a reaction on the board for you. And since I already, I haven't done one, it's my turn. And what do we have here that's different? Carbons. Ooh, carbonyl with a hydroxyl group. A carboxylic acid. What do we have here? Sodium bicarbonate. And this one I'll never give a synthesis problem on. And what do you get? All the products, you get the carboxylate anion plus water and the plus carbon dioxide given off as a gas. And that's what that arrow up means. So here's my R group, which means I don't break carbon-carbon single bonds. Here's my carbonyl, it's still there. This will now have a carboxylate anion. plus, since it asked, give all products, well, water plus CO2 given off as a gas, and that's what they are up means. Remember, this is all stuff for test number 3, not test number 2 that I'm giving this Wednesday. I'll wait for you to catch up. Anybody think about acetic acid is in vinegar is in ketchup? I got the rest of the semester still to work on you people, and I won't give up. Everybody caught up? All right, time for you to have some fun. Hold on. That looks better. And it's your turn. Remember, give all the product or products for the following reaction. All right. We look here. What do we have? What's different? Ooh, 2 oxygens. Remember, what's not carbon, what's not hydrogen, should get your attention like that. And we have a carboxylic acid. Plus baking powder, sodium bicarbonate. And what that gives, acid-base reaction, you get the carboxylate anion plus the carbonic acid formed from the sodium bicarbonate breaks down to water and CO2. So what's my R group? Isopropyl. Do you break carbon-carbon single bonds? No. Also have my carbonyl, oxygen minus, like you see down here, Na plus, carboxylate anion, plus, ooh, what happened to my nitrogen there? Or N, it's not really nitrogen. And then you'll get water plus, excuse me, CO2 given off as a gas. Move it down a little so I can draw it bigger. And that's what you get. Oh, let's do another one. And there you go. Thank you, Ignacio. Thank you, Andrew. Now, if we look at what's different? What's not carbon? What's not hydrogen? Oxygen's to the same carbon. Carbonyl, hydroxyl group. Then I have on that carbon, methyl. It's a carboxylate anion, or I want that, carboxylic acid. Getting ahead of myself. And sodium bicarbonate, baking powder. And what happens? Acid-base reaction. You get the carboxylate anion. Now I said it the right time. Plus water, plus carbon dioxide given off as a gas. So what's my R group? Methyl. So I'll get this carboxylate anion plus water plus carbon dioxide given off as a gas. Anybody see the significance or interesting aspect of that reaction? Give up? All right. What's this carboxylic acid? The common name is acetic acid. And where do you find it? In vinegar. And this sodium bicarbonate in baking powder. And now I get to tell you some history of Dr. White. When I was about 5 or 6, first of all, that was back in the 1950s. Wow, a long, long time ago. But here in the United States and the world, really, we were fighting sort of like what's going on now, but it was dangerous back then because we could have had nuclear war, sort of like what's happening now. We were at not real war, it was called the Cold War with the Soviet Union, which was made up of Russia, Ukraine, and some other satellite, Lithuania, and I think a couple other of the states around Russia. And at that time, the big thing that was going on was the space race. Who could be the first to get a satellite around the Earth with a rocket ship? Who could get the first man into outer space? And who could be the first on the moon? And because of that, for my age, for boys, all the best toys had anything to do with rockets, because that was the rage, the cool thing going on in the world, in the space race with the Russians or the Soviet Empire. Well, there was this candy that came in a tube It looked like a little rocket. Now, I have to warn you, I'm going to do some artwork and you're allowed to laugh, but don't break a rib laughing too hard. I have no artistic talent whatsoever. Zippo, zero. My mother was a very good amateur artist. My father was a very good amateur carver. He did some great work. She did too. Not one iota of it rubbed off on me. But let's take a look. Now, what they sold was, and it was about this big, a tube, and it had a cap that had 3 fins. So it looked like a rocket ship. I told you I wasn't a good artist. I'm not. But anyways, and inside the tube were these little dots of the most god-awful candy you've ever tasted. And how can they sell these for a penny a piece? And so you could get a couple of them when you're a little kid. But what did a 5 or 6-year-old do when he got them? You go over to a garbage can, take the cap off, dump the candy into garbage, and you had a little rocket ship to play with. Now you know it's really got to be bad candy if a 5-year-old throws it out, doesn't eat it. If it's anyway halfway good, you would, but it wasn't. Well, my father, being a pharmacist who loved chemistry, I wonder why I became a chemist. Well, I don't know. But anyways, he loved chemistry, showed me something really cool. If you took this tube out that was empty, turned it upside down, it looked like a test tube. If you put in some vinegar and baking powder and slammed the cap on again, you had the chemicals in there. Oh, that looks bad. Hold on. Even I can't stomach that. Let's try this again. Well, it still looks bad, but you gotta, and it's got the chemicals in here reacting. What reaction? This one right up here. And what was happening was it was making carbon dioxide, a gas that was building up pressure. And with time, wasn't that long, within about 20, 30 seconds, enough pressure would build up in here that this tube would go firing off. And when you're 6 years old, that's the neatest thing in the world. You held it and it'll go off. Now, if your timing was right, you got to do this quick. Put the baking powder, put some vinegar, shake it up, hold it like this. The cap would go off about 4 or 5 feet. And when you're a little 6-year-old, that's cool. Well, we did that, and I showed my friends, and I have to tell you this, my best friend at the time, and I haven't seen him in decades. He moved out of state long ago. But Dickie Gale, I still remember his name. If you're out there, Dickie Gale, send me an email. But anyways, I hope he's still alive. He used up all his mother's baking powder doing that. And that night she went to use it to cook something, and it was empty. Boy, did she get mad. And oh, did he catch it. Ooh, it was not pretty sight. I found out about it from his brother the next day and him too. I can't remember his brother's name, who was about 2 years older than Dickie. But anyways, so if you ever do this, don't use up all your mother's baking powder, and I'm sure don't use up all her vinegar. And if you go on YouTube, you can see, let's do that. Hold on. Bingo. Now they're doing much better than I did. So do not try this at home. Let's see, who's got the most? All right, this guy's got, or
Laura Murphy grew up in a middle-class family and worked in healthcare and social services for over 20 years. Now in the Senate, Laura's
sorry
fighting for
about
working
the ad.
families by taking out
7,
corporate
6.
interests and protecting a woman's right to choose. Because Laura Murphy believes in an Illinois that works for everyone.
Again, don't try this at home without safety glasses. Now they're getting fancy. Let's find another one. This is.
This time we're putting the baking soda inside a pop sock that's made out of pipes. Now hopefully that will mean that the vinegar can get inside the pop sock more easily and it won't get wedged in the end of the bottle when we're about to.
He's got pop. You could, or
the gas gets out more easily. Here we go then. So cut a little hole in the pop sock there and the gas. Push it on down. Here we go, and
he's doing it fancier than I did.
suspend it. That's a nice feature. Ready? 3, 2, 1. Over we go. Bubbling away nicely. Pop top looks like it's turned into a balloon.
And the bubbles are carbon dioxide forming.
Look at it go. Oh, that's very frothy. That's very frothy. Wow! Oh, success!
Again, do not try this at home. But when I was a little kid, you had just a little thing, and it wasn't as dangerous as that, even though, come to think of it, none of us ever poked our eyes out. We didn't have safety goggles on, but it was fun. Now, the other thing I want to share with you that is quite useful is my father loved to cook. He was a really good cook, better than my mother's, and she was a very good cook. He was better. Now, I have 2 sisters, and on Sundays when he didn't have to go to his drugstore for 10 years, he owned his own drugstore, and he had to go there Monday through Saturday to open it up and everything. He had Sundays off because it wasn't open on Sunday. Back then, nothing, very little was open on Sunday. Once in a while, he'd say Friday or Saturday, this Sunday, it's men only cooking, which meant me and my father. We had a huge deep chest freezer so we could make a lot of something and freeze it. My mother liked that because she could take it out, defrost it, and there'd be dinner ready to go. One of the things he loved to make, and was really good at it, was spaghetti sauce with meatballs. I won't go into the meatball recipe, but the spaghetti sauce, he uses knowledge of chemistry to improve it. And it's traditional, you know, you have tomato sauce, tomato paste, different herbs like oregano, garlic, onions in there, that stuff. And what I don't know how he ever found out this, but maybe he just experimented. Tomatoes have citric acid in them, and citric acid is a carboxylic acid. And I'll just write citric. And that's in the tomatoes. Have you ever had a canker sore, and if you had ketchup, it burns in there, it's not comfortable? I'm about to sneeze, hold on. Excuse me. And that's the citric acid doing its thing on your canker sore. Now, what he found was near the end, first of all, when he made it and used this technique, and we would make a lot, he had a 3-gallon stock pot that would make about 3 gallons of sauce and put it in quart containers and freeze it. I mean, we had a big deep chest freezer in our utility room in the basement. But anyways, he found out at the end, put some baking powder in there. And what would happen is you'd form sodium citrate, water, and plus the CO2 given off as a gas. And you'd see this as white bubbles at the top of the stuff. And in a big pot of 3 gallons, maybe a tablespoon, maybe 2 tablespoons, a tablespoon and a half at most, if that much. And what it did is it neutralized some of the citric acid. And by raising the pH and neutralizing it, it tasted milder and it made it really smooth. Now, one other thing, and I'll share the secret with you. Remember, it's a secret. And again, I don't know how he found out. If you've ever made your own spaghetti sauce and you taste it and say, that doesn't taste like the stuff I get at these fancy Italian restaurants. What's different? We found out, I don't know how, you put a pinch in 3 gallons, we're talking just a pinch of cinnamon. And maybe it was maybe a quarter teaspoon in 3 gallons, very small amount. And it gave it that professional, like the high-end Italian restaurant. And that's the secret he found out. I don't know who from, but now, interesting story. A couple years ago, I told you what I just did about how to put baking powder in the back, into the sauce at the end. Not too much. And by the way, cinnamon, be real careful. I had a friend of mine, I told that he made a small pot, he put a tablespoon of cinnamon in there, and all you could taste was cinnamon. You couldn't even taste the tomatoes. He overdosed it too much. So be careful, just a little bit. But anyways, the student, a couple weeks after I explained to the class how my father would, and I do it still to this day when I make spaghetti sauce or good marinara sauce, which is essentially spaghetti sauce, but a little thicker, some baking powder. And the other thing I should mention, if you notice the carboxylate anion, to your tongue, that tastes like salt. So even though you're putting a small amount in of baking powder, we always cut back a little on the salt we use. Just a little, but not, anyways. So the student came to me and said, thank you. And I said, all right, you're welcome. What are you thanking me for? And she said, well, we made the spaghetti sauce and used the sodium bicarbonate at the end, and it was delicious. I was happy. I'm glad someone enjoyed that. And she said, but I really have to thank you. And I said, for what? So, well, my father and I suffer from acid reflux. And if you've ever heard about that, it's where you get some of the intestinal acid fluids come up your esophagus. And I worked at one company where another section head, he had it so bad and it was so painful, acid reflux, he had to have an operation to try and fix it so it wouldn't come up. Anyways, she said, my father and I love spaghetti sauce or spaghetti and meatballs, but the acid in the tomatoes, we'd suffered and really bad. It would be painful. Well, when we made your sauce, because a lot of the citric acid is neutralized by the baking powder, it wasn't painful. So I thanked her for sharing that. It made me happy that I helped them out. And my father's recipe got to use elsewhere, and that was a good thing. So if you ever want to do the rocket ship, it's also called the baking soda volcano, if you look on YouTube. And if you ever make the spaghetti sauce, you don't have to put a lot in, maybe a quarter teaspoon if you're making a quart or two, and put just a pinch of cinnamon, because it goes a long way, but that pinch of cinnamon gives it that professional high-end Italian restaurant taste. If I look at the clock, oh my goodness, we're just about done. Don't forget, Wednesday after our class, I'll be giving out the password for test number 2. You'll have until Thursday, 1 p.m. to do test number 2 and hand it in by uploading it to D2L. Also, don't forget, as of last week, new office hours, they're now Tuesday and Wednesday from 6 to 7:15. If you have any questions, come on by or need any help. Also, if you really need help and or something you need to get to talk to me about, always feel free to email me and I'll see if I can set up a Zoom meeting when we're both available. And with that, I'm done for today. I get to put out the garbage tonight. It's Monday night. And with that, gang gesund. I'll see you on Wednesday. Bye.